All right, in 7.5, we are continuing on with confidence intervals, and we are going to look at means. In 7.3 and 7.4, we looked at proportions, and now we're going to try to estimate a mean. So like confidence intervals for a population proportion, there are conditions that need to be met to construct a confidence interval for a population mean. So these are the two conditions. Notice they should look familiar. The first one is random, that the data come from a random sample from the population of interest. And then we have to know it's normal or large enough. So with the means, if you recall, we talked about the central limit theorem, and we can know that it's normal or large really two ways. We know that the data come from a normally distributed population, or, there's a big or there, it's one or the other, or the sample size is greater than or equal to 30. Okay, so we have to stop and consider, can we call it normal because they told us it's normal, or because the sample is 30 or greater. So when the random condition is satisfied, we can generalize about the population from which the sample was selected. When we check the normal large sample condition to make sure the distribution of x bar, the mean of our sample, is approximately normal. All right, so confidence intervals are made up of two parts. And we've talked about this, the point estimate and the margin of error. Okay, so the confidence interval for a population mean is this. X bar, this is our point estimate right here. And all of this back here is the margin of error. Okay, just like it was with proportions. But the problem is, notice we have sigma here. Sigma is the population standard deviation. Well, we're trying to estimate the population mean, so that means we don't know it, which probably also means that we don't know the population standard deviation. We don't know that. So there has to be another way to find confidence intervals, all right? So we're going to use another distribution that's called the t distribution. So when calculating a confidence interval for a population mean, we use a t star critical value rather than a z star critical value. Whenever we use S, where S is the sample standard deviation, okay? The sample standard deviation. If we have our sample, we probably know that. We don't have sigma. We don't have anything about the population. We're trying to estimate that. All right, so how do you remember that T goes with means and Z goes with proportions? Well, just remember this, zap tax. Okay, we use Z star with proportions, and we use T star with means. X bar is means, right? So if you remember zap tax, that'll help you keep straight which one do you use when. So to find the T star, you're going to work it the same way we did before. You know, we drew the curve and we put like the 90% confidence interval would be 0.9, so that leaves 0.10, and we divide it by 2. So the area over here is 0.05. Okay, so typically we put that in a calculator in inverse norm, right? Well, that's where we're different. We're not going to use inverse norm. We're going to use inverse t, which is the fourth option. We put in the area we wanted. Now, with the t distribution, we have to use something called degrees of freedom. All right, it's very complicated. You don't care what it is. But here's what you need to know. You have to know what the degrees of freedom is, but it's really easy to figure out. Here it is. Write this down. Degrees of freedom is n minus 1. Okay, so whatever your sample size is, minus 1. All right? So we'll go through some examples of how to do this in a minute. Because we almost never know the population standard deviation in sigma, we must use the sample standard deviation, which is the S, as an estimate for sigma. This means that we must estimate the standard deviation of the sampling distribution of x bar, standard error of x bar. All right, so the standard error of x bar is this. Write this down. It's an estimate of the standard deviation of the sampling distribution. So this should look a little bit familiar. We did something very similar when we did sampling distribution. We just happened to put sigma on the top here. Well, we don't know sigma. All we know is our sample standard deviation. But notice we're still dividing by the square root of n like we did before. Okay? So when you use the sample instead of sigma, we call it the standard error. All right, and the standard error of x bar estimates how much x bar typically varies from mu. Okay? So when the random and normal large counts conditions are met, a confidence interval for the unknown mean is this. So here it is. Here's your structure. Write it down. X bar, that's our sample mean. Okay, what is that? That's the sample mean plus or minus t star times Sx, that's the sample standard deviation, divided by the square root of n, which is your sample size. Okay, so we're going to walk through this. Remember, when you do t star, you have to know degrees of freedom. So remember, degree of freedom is n minus 1. And it's going to give you an area under the curve. Okay, so it's going to look a lot like proportions. We just have to remember to use t star instead of z star. So number 1, how much time do students at your school spend on the internet? You collect data from a random sample of 32 students at your school, and you calculate the mean amount of time that each student spends on the internet every day. So this question just says, determine if the conditions are met for calculating a confidence interval, right? So the first condition, remember, is it random? Okay? It says a random sample of 32, so we can say random sample, n is 32 students. So there's the first condition. It is met. The second condition, is it normal? Remember, how do we know if it's normal? Either they tell us the distribution is normal or the sample size is greater than 30. Well, they didn't tell us how the shape of our distribution. So since n is equal to 32, it's greater than or equal to 30, and I can put a check because of the central limit theorem. Okay? You need to write it like this: n equals your sample size greater than or equal to 30, and refer back to the central limit theorem. So those are the two conditions you have to check. So the first couple problems in your problem set, you're just checking conditions. All right? Number 2, what critical value t star should be used in constructing a 90% confidence interval for the population mean with n is equal to 10, randomly selected observations? So we're going to do the same steps we did for z star. Draw the curve, put 0.90 here. That means that 0.10 is left, so this is 0.05, and this area over here is 0.05. Okay, so what am I going to do? I'm going to do second bars, and I'm going to go inverse t, right? Inverse t, and then it's going to ask me for an area, and it's going to ask me for a df. That's degrees of freedom. So area is 0.05. Degrees of freedom, remember, is the sample size minus 1. So 10 minus 1 is 9. So let's type this in and see what we get. So second bars. Notice number 4 is inverse t. So click on that, and it's going to ask you area, 0.05, and then degrees of freedom is 9. Hit paste, hit enter, enter one more time. So my t star value is 1.833. Okay, so t star equals 1.833. Don't worry about the negative. You can drop the negative. Okay, so just like before, you're going to have a couple problems where you just have to find the t star part. All right. Now look at number 9, or sorry, example 3. How many licks does it take to get to the center of a Tootsie Pop? Researcher Cor Hyde decided to find out. He instructed a sample of 92 students. Okay, so that's pretty key. Sample of 92 students to lick a Tootsie Pop along the non-banded side until they could taste the center. The mean number of licks was 356.1 with a standard deviation of 185.7. Construct a 95% confidence interval for the true mean number of licks it takes to get to the center of a Tootsie Bar or Tootsie Pop. Assume the conditions are met, so we don't have to worry about that. Okay, so now let's go back and look at the numbers we circled and name them. Okay, 92 is my sample, so n is 92. So automatically I know my degrees of freedom is 92 minus 1 or 91. Okay, now it says the mean number of licks, So this is a mean of a sample, so I use X bar, and it's 356.1. The standard deviation is 185.7. But remember, the symbol for standard deviation of a sample is S with a little x. Okay? So knowing all those things, then we think back to our formula. It says X bar plus or minus T star, and then S over the square root of N. So the only part of this we don't know yet is our T star value. So let's figure out T star. All right? This is a 95% confidence interval, so I put 0.95 in here. That means I have 5% left, right? 1 minus 0.95 leaves me 0.05. Divide that by 2 because there's 2 tails. So the area in each tail is 0.025. So when I do inverse T, the area I want is 0.025, and I know my degrees of freedom is 91. Let's see what T value or T star value I get. So I get 1.99. That works, okay? So 1.99. Now, put this all in your confidence interval. You need to put it, show me this work. 356.1 plus or minus 1.99. Then the standard deviation that we got was 185.7 divided by the square root of our sample, which was 92. Now, in your calculator, there is a test that will help you do this. Okay, so you're going to go to Stat, Test, right? And it's number 8, T interval. Do you see it? T interval. All right, so T interval is what we want, and you have two options, data or stats. You'd only use this data thing if you had put the data in the lists. Okay, so in this problem, they gave us the statistics of our sample, so we're going to use stats. So we're going to have to input what is the X bar in the problem, which was 356.1, and then S, the standard deviation, is 185.7, and then our N value, which was 92, and confidence level is 95%. Calculate. So there's my confidence interval right there. Okay, so I'm going to copy this. All right, so on that problem, all I have to do is construct the interval and show the answer. Okay, we are going to eventually interpret this, and we would say we're 95% confident that the true mean number of licks to get to the center of a Tootsie Pop is between 317.64 and 394.56. Okay, we'll get there. We're not there yet. Right now, I want you to just practice the mechanics of building your interval. All right, we'll see you in class.